Welcome to Pod 2, Lesson 3. What is normal? In today's lesson, we are going to be talking about normal models, using a normal model, z-scores, and comparing your normal models and your z-scores. Our essential questions are, what is statistics, and what is a normal model, and how can it be used? Standard deviation. We learned in the previous lesson, standard deviation is used when comparing different looking values. It does tell us how much the whole collection of values varies. You can compare how far off things are from the standard deviation to determine certain things about two different events. On page 115 in your textbook, you are given an example of the long jump and shot put. Your long jump was more impressive than the shot put throw, since the long jump distance was further above that standard deviation than the shot put. Z-scores. You need your standard deviation in order to find your z-scores. So you're going to subtract the mean and the real score, then divide by the standard deviation. It gives you an indication of how unusual a value is because it tells you how far it is from the mean. How you find your z-score. The z-score equals the actual score minus the mean divided by the standard deviation. Your z-score does not change the shape of your distribution. It does change the center by making the mean 0, and does change the spread by making the standard deviation 1. So on one test, your class achieved an average grade of 80 with a standard deviation of 8 points. We're going to work on these 3 problems in order to use the z-score. If you would like to try them on your own, please pause your video and you are welcome to do so. So if you got a 96 on your test, that means you had 96 minus 80 and your average, your z. So here's your score, here's the average, or your mean, and here's your standard deviation. 96 minus 80 is 16, divided by 8 gives you 2. So your z-score is 2. Please pause the video and try B. You should have gotten negative 0.5. If you forgot your negative, that's probably because you didn't write that it should be a negative 4 up top. So you have negative 4 divided by 8 equals negative 0.5. The next part says, what test grade has a z-score of plus 1.5? That means you don't know your test score, minus 80 over 8 equals 1.5. Please solve this equation. You should have gotten x equals 92. So that means you need, if you want a z-score of plus 1.5, you need to get a 92 on the test. Normal models. It's a distribution whose shape is unimodal and roughly symmetric. You represent a normal model with a mean of your Greek U and a standard deviation of your Greek O. It would look similar to this. Your standard normal model. The mean is 0 and a standard deviation of 1. When you're working with a normal model, make a picture. Always make a picture. Even statisticians make a sketch, so should you. With a normal model, you have the 68, 95, 99.7 rule. That means 68% of your data is within -1 and 1 of your mean. 95% of your data is between -2 and +2 of your mean. And 99.7% of your data is between -3 and +3 of your mean. So say it takes you on average 20 minutes to drive to the movies. With a standard deviation of 3 minutes, suppose a normal model is used for your driving times. Use the 68, 95, 99.7 rule to solve the following problem. First thing you want to do is sketch out your normal model. Please take a moment to do that on your own. Pause your video, and when you are done, come back. So question A, about how often will it take you between 17 minutes and 23 minutes? If you think about your normal model, that means it is between 17 and 23. What percentage of your data falls between -1 of your standard deviation and +1 of your standard deviation? You should say 68%. So your answer to this question is 68%. How often will you arrive at the movie in less than 23 minutes? That means you're looking from this time down. So you know this is 68. You want to think, what are these two? If your entire thing is 95, how much is right here? And if your entire thing is 99.7, how much goes here? Take a moment to pause your video and find that number. You should have gotten 13.5 and 2.35. Add those up. You should have 83.85%. Please read letter C and then try that one on your own. You should have, in the end, gotten 2.5 as your answer. If you did not, please go back and try again. Using the z-table. You can use the z-table to find your answer as well. If you do not have the z-score, you can find it. Use your z-score table to determine the area. Subtract your two areas and convert it to a percent. So if we look at this problem here, we know that we have -0.7 and 1.2. Using your z-score table, please go and find the z-score for -0.7. You would write that there. You then go to the z-table and find the z-score for 1.2. That goes here. Subtract the 2 and round to a percent. You should get 0.643 which is 64.3%. You can also find your z-score when you are not given the exact numbers. You will also need to use your z-score table. So if you know one standard deviation is 25, you can find how much off of your standard deviation this number is. You need to find the difference between 75 and 85, which is 15, and divide that by what your z-score is, which is 25. You would get 0.6. This means you're 1.6 away from your mean. So the area would be your z-score is less than negative 1.6, which is 0.055. Please complete your homework assignment. If you have any questions, feel free to contact me. Thank you.